Good morning. This is your stat sensei, Mr. Spensey, and this is observation versus experiments multiple choice, and this is going to be problems 11 through 20. So consider the following studies being run by three different nursing home establishments. One nursing home has pets brought in for an hour a day to see if patient morale is improved. Oh, that's really nice. We're um, are there two different groups? Was there a random assignment? And the answer is no. So this makes this a observational study, no randomization. No randomization, no random assignment. One nursing home allows hourly visits every day by kindergarten children to see if patient morale is improved. Oh, that's really nice too. There's no random assignment. This is an observational study. One nursing home administers antidepressants to all patients to see if patient morale is improved. Good. Over medicate them. Great idea. Is there a random assignment? No, it was assigned to all. There's in both, so no random. So this is an observational study. And the other thing is we don't have any control groups. We don't have a group. Everybody in the nursing home saw patients. No control group. We didn't have a group that didn't get to see them. In this one, kindergartners went to all the patients. No control group. Everyone saw it. So let's look at these. None of these studies are used randomization. That's true. None of these students use a control group. In other words, in this one, we brought in pets, but there's no group that didn't see pets. They all saw pets. So because they all saw pets, no control group. That's true for this one. Kindergartners, they went to all the patients. We had no group that didn't see the kindergartners. In this group, everyone got drugged. So once again, there's no group that didn't get the antidepressants, so there's no control group in this case. None of these use blinding. Blinding is something we haven't really talked about yet. Blinding is when either the person administering the treatment or those receiving the treatment don't know what they're getting. Well, in this case, we know if you're seeing a pet, and the patient knows if they're seeing a pet. In this one, both the patient and the administrator knows if you're seeing kindergartners. In this one, the patient knows they're getting a drug, and so does the administrator. So there's no blinding. Important information can be obtained from all these studies, but none will be able to establish a causal relationship. Causal relationships can only be done by experiments. These are observations. All of these are observations, so no causal relationship. This is true. So E, all of the above are true. All right, moving on to number 12. In a 1927 to 1932 Western Electric Company's study on the effect of lighting on worker productivity, productivity increases with each increase in lighting. Okay, so I would conclude that if I turned up the light, worker productivity increased. But then it also increased with every decrease in lighting. Well, wait a second. If I increase lighting, it increases, and I decrease lighting, it increases. That doesn't make sense. Why? It's called the placebo effect. It's like when you get well, when you're given a sugar medicine. Some people go, oh, they have such a positive vibe that they do better. Well, here we changed the lighting and there was a positive vibe and they did more. Here they decreased the lighting and they still did more work. All right. So really, lighting had no effect. All right. Lighting had no effect. It's just that people thought that it would. That's actually a tough question, to be honest with you. Number 13, when the estrogen blocking drug tamoxifen was first introduced to treat breast cancer, there was concern it would cause osteoporosis as a side effect. To test this concern, cancer subjects were randomly selected and given tamoxifen, and their bone was measured before and after. All right. So the before and after is important. That means they got tested twice. If they get tested twice, that's called a matched pairs. And because they were randomly selected, this is an experiment. Because tested twice, this makes this the matched pairs experiment. So the subject was an experiment in which the subjects were used as their own controls. All right. So what were you before? What were you after? So this matched pairs experiment, by the way, are the most powerful experiments. We'd love to do them all the time because a matched pair experiment controls for all the differences in an individual, are in individuals, because you are exactly who you are, and there's no one else like you. And so this controls for any differences between individuals. So in a match paired, it they everyone is their own control. In a match paired, that's just part of it. So this is an experiment because they were tested twice and they were randomly chosen. All right, which of the following is incorrect? By the way, increasing size decreases error. Blocking is to an experiment design as stratification is to sampling design. All right, blocking says I'm going to break it down into groups based on a common characteristic. Stratification, I'm going to break it down into groups based on a common characteristic. Sounds like I said exactly the same thing. I could put men in one group and women in another group. So that would be blocking, and that would also be stratifying. Blocking would be for experiments, and you only use the word blocking for experiment. Stratification, you only use for sampling. So this is a true statement. All right. By controlling certain variables, blocking can make conclusions more specific. Yes, because perhaps the hormone medication impacts men differently than it does women. So that's also a true statement. The paired comparison is a special case of blocking. Yes, paired is a special case of blocking. You're blocked on the actual individual. The individual is the blocks. All right, each individual is a block. Blocking results in decreased error because the blocks have smaller size than the original group. No, increasing sample size decreases error. Having smaller blocks does not decrease sampling error. Sampling error is decreased because of increasing sample size, not as a result of blocking. In a randomized block design, the randomization occurs within the blocks. That's true. That means we force you into blocks and then we randomly select or randomly assign in a block. Remember in stratification, you were placed in a strata based on your characteristics and then randomly assigned a treatment. All right, number 15. Is hot oatmeal with fruit or a Western omelet with home fries a more satisfying breakfast? 50 volunteers are randomly split into two groups. One group, randomly split. Well, I don't like that word split. That's tricky. But that's like using the word randomly assigned. Guess what? That makes this an experiment. All right. And if the Western omelet with the home fries receives a substantially higher average score, what's a reasonable conclusion? Were treatments assigned? The answer is yes. So they liked it better. Can we make this statement? In general, people find Western omelets with home fries more satisfying. Can we make that conclusion? The answer is yes. We can say this is causation. We can say causation. We can draw a conclusion. And the reason we can do this is because this is an experiment. They were randomly assigned. All right. There's no reasonable conclusion because the subjects were volunteering. You always most of the time for experiments, unless you're like the Nazis, you are randomly assigned. I mean, randomly, excuse me, you have to volunteer for experiments. Most people can't have experiments forced on them. So volunteers are always going to be used, whether it's an experiment or observational study. There's no reasonable conclusion because of the small sample size. This is not really a small sample size. Small sample sizes would be substantially less than 30, so this is not a small sample size. There's no reasonable because blinding was not used. You know, blinding should be used, but it doesn't have to be used. That's not what shows causation. There's no reasonable conclusion because there are too many confounding variables. Um, maybe, but in general, people find Western omelets and home fries more satisfying than uh, is. We can make that statement because this was an experiment. So because it's an experiment, we can make the statement. All right. Which of the following is a true statement? In well-designed observational studies, responses are systematically influenced. No, systematically influenced is another way. This right here is another way of saying assigned. We do assignment in experiments, not in observational studies. So this is a false statement. In well-designed experiments, the treatment units result in responses that are as similar as possible. No, not similar as possible, different. A well-designed experiment randomly assigns treatments. That's true. Causation and association are unrelated concepts. No, they are very related. Association says there's a relationship, a correlation says there's association, etc. Um, cause causation and association are causation and association are unrelated concepts. That's a tough one. Let me think about that for just a moment. Thinking. They're similar, but there's a problem. Causation is for experiments, association is for observational studies. So they're related, but they're not exactly the same. So I'm going to put a question mark by that. E, in a well-designed, well-conducted experiment, strong correlation association means that there is a cause and effect experiment. Um, and that's true. So we have a problem with this question because we have more than one right answer. Um, E is the one we chose, but honestly, C, a well-designed experiment randomly assigns treatment. That's true. Um, C and E are good answer choices. This problem needs to be revisited and cleaned up. All right. Apologize for that. So yeah, C and E are good answers, and we marked E, so you probably should as well. Number 17, which of the following is not which is not important in the design of experiments? Controlling of confounding variables. Yes, control is super important for all experiments. That's a true statement. Randomization is assigning subjects to different treatments. We have to have randomization for assignment. Replication, that's a requirement for all experiments. Care and observing without imposing treatments. False. We impose treatments. The word assign means impose. So treatments are imposed. So that's false. All right. Isolating variables to different blocks. Yes, that's part of control. We like doing that. We go, hey, there's a difference between men and women, so we're going to put them in different blocks. So our best answer choice is 17 is D. All right, 18. Which of the following is a true statement about the design of a matched pair experiment? Remember, in a matched pair experiment, we're either working with like twins or you're being tested twice. All right. Each subject receives both treatments. Yes, that's true. Each pair of subjects receives the identical treatment and differences in their responses are noted. Um, there may or may not be. So this is kind of true, not as good. Blocking is one form of a match pair. No, that's swap. Match pair is a form of blocking. So they just swap the order. Match pair is a form of blocking, so this is false. Stratification into two is an example of match pairs. Stratification is for surveys. Blocking is part of match pairs, or match pairs are part of blocking, so that's false. We should not use stratification when we're talking about experiments. Randomization is unnecessary. That's false. Randomization is always necessary. So the problem with here is we don't necessarily have a pair. Sometimes we only have one person being tested. If we only have one person, we don't have a pair. So the best answer is A. B is not a bad choice, but A is a better choice. 19. Some researchers believe that too much iron in the blood can raise the level of cholesterol. The iron level in the blood can be lowered by making periodic blood donations. A study is performed by randomly selecting half a group of volunteers to give periodic blood donations while the rest do not. Is this an experiment or observation? All right, so we randomly said half. So we randomly assigned half to give blood and randomly assigned the other half not to. Because we have random assignment, this is an experiment. All right. I want to break something in here. It says with a single variable. So in this case, we randomly assigned to give blood, not give blood. And at the end, we're going to compare results. Well, right here, because I only have one division, that means I have one variable. I have one variable with two possible results, or two levels. One variable, two levels. The levels is whether you gave, the levels is donating blood, and you either gave blood or you did not give blood. All right, so those are the two levels. All right, that's what that means. 20. Do teenagers prefer sports drinks colored blue or green? Two different colorings have been no effect on taste are used on the identical drink to test result in a blue and green beverage. Volunteer teenagers are randomly assigned to drink one of the colored beverages, and the volunteers then rate the beverage on a 1 to 10 scale. So they were randomly assigned. So if they randomly assign, this is an experiment. Because of the concern that sports interest may affect the outcome, the volunteers are first blocked by whether or not they play on a high school team. Is blinding possible in this experiment? Well, blinding means I don't know what color I'm drinking. Well, if I'm testing color, then I have to see the color. All right. No, because the volunteers know which treatment, which in this case is color, they are receiving. All right. They know if they're receiving a blue drink or green drink because that's what we're testing. We're testing to see whether color impacts things. Because some beverages take very, very similar, but if they're a different color, you may or may not choose them. And by the way, if you don't believe me, try it with little kids. They'll always go for bright colors as opposed to the ones that are not as pretty. All right. Um, Appreciate you watching. I hope this helps, and I apologize for the one question is a little bit unclear. Thank you.